Hi, I am Mr. Peck from Ideas Inc. School, and today we will be discussing about enzymes. We begin by talking about the properties of enzymes. First of all, enzymes are biological catalysts which are made of protein. Secondly, enzymes alter or speed up a chemical reaction and they remain chemically unchanged at the end of the reaction. Lastly, enzymes can catalyze anabolic reactions which facilitates the building up of complex substances. Enzymes can also catalyze catabolic reactions which causes the breakdown of complex substances into simpler ones. Next, let's discuss about the characteristics of enzymes. As mentioned previously, enzymes can speed up chemical reactions. And since enzymes remain chemically unchanged at the end of the reaction, they are only required in small amounts as they can be reused. The next characteristic of enzymes are that they are very specific in their action due to its specific 3D shape of their active site. The active site is an area on the enzyme where the substrate can dock in to form an enzyme-substrate complex. Lastly, enzyme activity can be affected by changes in temperature and pH. So why are enzymes so specific in their actions? This is due to the lock and key hypothesis. The enzyme, the lock, has an active site with a very specific 3D shape. Therefore, only a substrate, which is the key, with a 3D shape that is complementary to the active site can fit. As a result, only compatible enzyme and substrate will combine to form an enzyme-substrate complex. Chemical reactions will then occur and the substrate is broken down into simpler products. At the end of the reaction, the products will detach from the active site and the enzyme remains chemically unchanged. On to the main part of this chapter. What are the effects of temperature on enzyme activity? At low temperatures, the enzymes are inactive. The enzyme and substrate molecules have low kinetic energy. As a result, the frequency of effective collisions between enzymes and substrates are low. Thus, the rate of enzyme-substrate complex formation is low. However, as temperature increases, the molecules gain kinetic energy. This causes the frequency of effective collisions between enzymes and substrate to occur more often. Thus, the rate of enzyme activity increases. For every 10 degrees Celsius, the rate of enzyme activity doubles. This trend continues till the optimum temperature is reached. When that occurs, the enzyme activity has reached its maximum. Unfortunately, when the temperature goes beyond the optimum, irreversible denaturing occurs. Denaturing is when the bonds that maintain the enzyme's 3D shape are being overcome. The active site loses its specific 3D shape and the enzyme will no longer be specific to its substrate. Since the shape of the substrate and the shape of the active site is no longer complementary, these molecules cannot bind together to form the enzyme-substrate complex. As a result, the rate of enzyme activity falls rapidly to zero. Next, we will discuss about the effects of pH on enzyme activity. Enzymes behave differently when exposed to different pH ranges. Moreover, enzymes are pH buffers and they can withstand minor changes in pH. Thus, minor changes in pH only causes reversible changes. Only when the enzymes are exposed to extreme changes in pH will they start to denature irreversibly. This denaturing process is similar to what an enzyme experiences when it is exposed to high temperatures. Lastly, we will discuss the effects of substrate concentration on enzyme activity. Please pause the audio and refer to the notes for a better understanding. Let's begin. In this experiment, we are keeping temperature, pH and enzyme concentration constant. The only independent variable being changed is the substrate concentration. At the beginning, when the substrate concentration is low, not all of the active sites found on the enzymes are being utilized. Therefore, as substrate concentration increases, the rate of reaction increases proportionally. This is because the substrate concentration is currently limiting the reaction. As more and more substrate is added, the rate of reaction will start to decrease as more active sites are being occupied. This trend will continue till all the active sites are used. At this point in time, the enzymes are saturated with substrates and are no longer limited by it. When this happens, the rate of reaction does not increase further and has reached a constant rate of reaction. Now the reaction is limited by enzyme concentration instead. As a result, only when there is a further increase in enzyme concentration will the rate of reaction increase again. We have come to the end of this chapter. If you have further questions, please approach Mr. Peck. Thank you for listening and have a nice day.